Another method, இது வந்து instead of oxidizing, this method uses reduction. If you have an acid chloride ArCOCl or RCOCl, the ArCOCl or RCOCl are derivatives of acid. Acid வந்து SOCl ஓட sulfonyl chloride ஓட react பண்ணாக்க you get RCOCl or ArCOCl depending upon what you start with. In the RCOCl allata ArCOCl in the reagent is a special reagent. Normally the reducing reagent, which is powerful, is lithium aluminum hydride. This is 4 hydrogens. This is normally used for very powerful reduction. If you have the aldehyde group, it will reduce it to RCH2OH. If you have a ketone group, it will reduce to RCHOH. R. Rendu R இருக்கும், the CO will become CHOH. But when you treat this lithium aluminum hydride with 3 molecules of ஒவ்வொரு ஹைட்ரஜனும் it is replaced by tertiary butoxide group CH3 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 CO. H will react with 1 H here, will form H2, gas will be evolved. So this is called tri-tertiary butoxy alumino lithium tri-tertiary butoxy aluminohydride. இதில் வந்து ஒரே ஒரு ஹைட்ரஜன் இருக்கு, 3 butoxy group இருக்கு. The butoxy group எல்லாம் very big groups. You have 4 carbon, the methyl group, each methyl group has 3 hydrogens. அதனால இது பல்க் ரொம்ப ஜாஸ்தி. அதனால இதனுடைய ரியாக்டிவிட்டி ரொம்ப குறைச்சி போடும். ஒரே ஒரு ஹைட்ரஜன் தான் இருக்குது, இதில் 4 இருக்குது, இதில் ஒன்றே தான் இருக்குது. இதனுடைய ரிடக்டிவபிலிட்டி ரொம்ப குறைச்சல். அதனால வந்து when it is reacted, ஒரு ஹைட்ரஜன் இதை ரீப்ளேஸ் பண்ணிவிட்டு RCHO ஃபார்ம் ஆகுது. அதே மாதிரி ArCHO ஃபார்ம் ஆகுது. திஸ் இஸ் எ வெரி ஸ்பெஷல் ரியேஜென்ட். இது ரொம்ப நாள் ரிசர்ச் பண்ணி கண்டுபிடிச்சாங்க. லித்தியம் அலுமினியம் ஹைட்ரைட் யூஸ் பண்ணாக்க ஆல்டிஹைட் ஆகிடுறதுன்ட்டு மெயினாக யூ வாண்டட் லித்தியம் அலுமினியம் ஹைட்ரைட் யூஸ் பண்ணாக்க ஆல்கஹால் ஆகிடும் ஆர் ArCH2OH. ஸோ இட் வில் ஸ்டாப் அட் திஸ் பாயிண்ட் இஃப் யூ யூஸ் திஸ் lithium tri-tertiary butoxy aluminohydride. Next is aldehyde formed from phenol. We have seen this reaction in phenol and its reactions. If you take phenol and react it with chloroform and hydroxide, you form orthohydroxy benzaldehyde. This is called the Reimer-Tiemann reaction. So you take the CHCl3 OH minus. This OH minus abstracts a proton. In the CH3Cl the hydrogen on the proton abstract panni it forms water. So the remaining CCl3 becomes a negative ion. The negative ion chlorine can easily get removed as chloride minus. You form what is called a dichlorocarbene. Notice here the carbon has only 3 bonds. These two, one bond pair, another bond pair, and the CO group this lone pair is another 2 electrons. So it is 6 electron. It has an empty orbital because carbon should have 8 electrons. It has 6 electrons. Because it has an empty orbital, it is very reactive. The reagents which are electrophilic will attack that carbon. The electrophilic molecule on the phenol phenol and the lone pair will come here. This double bond will move to this, and you get a CCl2 minus. This electron is carried over here, becomes CCl2 minus. In the இடத்துல ஒரு hydrogen இருக்கும், அது will get removed as a proton. இது OH plus இருக்கும் இந்த movementல, அது again it comes back as OH. The molecule that is formed is OH, ortho positionல CHCl2. இதை hydrolyze பண்ணாக்க sodium hydroxide இருக்கு, இது easily hydrolyzed. 2 hydroxy groups are formed on the same carbon, therefore it will become a ketone. The C double bond O, there is only hydrogen here, therefore it will become an aldehyde, orthohydroxy benzaldehyde. இது வந்து only ortho வருது, அதுக்கு main reason is in the lone pair வந்து it has some attraction to be close to this OH group, like hydrogen bonding. That's why the incoming group, the dichlorocarbene, gets attached to the ortho position. You don't get any para hydroxy benzaldehyde. The aldehyde group, ketone group the CO இருக்கிறது C delta plus and O delta minus. And the delta plus வந்து it pulls the electron of the C bond and CH bond. Another CH bond is easily broken as proton, and the carbon will become negative. Because of that, the simple reaction that takes place so in the minus வந்து இங்கேருந்து இந்த கார்பனுக்கு போயிடும். You get இது கிடையாது. The CH2 minus, because in the particular carbon the hydrogens are acidic, can be removed as a proton. You get anion. The anion is stabilized by the COH group because it can go into the bond here and oxygen can. This is generally referred to as keto-enol tautomerism. This can become this is called enolate ion. This is the corresponding keto compound. Because of this, formation of the CH2 minus ரொம்ப easy. The proton abstract பண்ணிட்டு the negative charge goes on to CH2 minus. Once in the CH2 minus in the intermediate form ஆயிடுதுனாக்க it reacts with another molecule of acetaldehyde. It will go and attack on the acetaldehyde molecule. CH2 minus attacks here, and the one of the bonds, double bonds, go to oxygen, and eventually it gets protonated. This particular compound is called Aldol. The reaction is called Aldol condensation. There is a slight modification of this Aldol condensation. Instead of using just aldol, aldehyde, acetaldehyde, you have a mixture of acetaldehyde and ethyl acetate. In that case, this methyl acetate the CH3 forms CH2 minus and condenses with aldehyde to form this double bond CH3 CH double bond CH. முதல்ல இந்த மாதிரி ஆல்கஹால் ஃபார்ம் ஆகும். இந்த CO இருக்கிறதுனால the conjugation அதனால C double bond C ஆகிடும். அது OH plus H will form water. அதான் இங்கே காமிச்சிருக்கு water formed. This form CH3 CH double bond CH COOET. These are all reactions similar to Aldol. Now you have another type of reaction which is based on the same principle of generating a negative center which adds to the carbon, the carbonyl group, which is delta positive. The Wittig reaction, the acetone plus CH3 CH2Br in presence of triphenyl phosphine. This compound is called phosphorus. Can be either in valency 3 or valency 5. This is a valency 3. 3 aryl groups are attached, 3 phenyl groups are attached to phosphorus. This is called triphenyl phosphine. In the presence of sodium hydroxide, the C double bond O is converted to C double bond C. This portion of the molecule condenses with CO to form C double bond C H and methyl. H and methyl group comes from here. The way this reaction takes place is shown here, the mechanism of this reaction. This triphenyl phosphine attacks the carbon of the alkyl halide, that CH3 CH2Br. This is CH3, is the CH2. The bromide will be broken up with the phosphine attached. When the phosphine uses this double bond, this lone pair, it will become positive. The phosphonium ion, triphenyl phosphonium ion, ethyl triphenyl phosphonium ion. When this is treated with sodium hydroxide, இந்த பாசிட்டிவ் சார்ஜ் நிறையா இருக்கிறதுனால இந்த ஹைட்ரஜன் வந்து அசிடிக்காக இருக்கும். இட் will be pulled off by hydroxide. இங்கே anion ஃபார்ம் ஆகும். Now in the triphenyl phosphonium ion is set up nicely. The anion வந்து attacks the delta positive of the carbon. The double bond moves to form a bond with triphenyl phosphonium group. And the resulting compound is this 4-membered ring, the triphenyl phosphine forming a bond with the oxygen, this methyl ethyl bromide, it will form a compound like this. And now the reaction, the 4-membered ring will open to form triphenyl phosphine oxide, and this side it will form a methyl group. So this is a very interesting reaction, very useful to produce certain kind of double bonds, the alkenes which are not easily available by other methods. Next we go to Claisen-Schmidt reaction, which is similar to the Aldol condensation. There two acetaldehyde molecules ஒன்றுக்கு ஒன்று react பண்ணி aldol form ஆச்சு. இங்கே வந்து benzaldehyde is reacted with acetaldehyde. The acetaldehyde will form, இங்கே வந்து CH3 group இல்லை, இந்த phenyl group இருக்குது. இங்கே வந்து ஹைட்ரஜன் கிடையாது, அதனால் இதில் anion ஃபார்ம் பண்ண முடியாது. இதில் தான் anion ஃபார்ம் பண்ணலாம். ஸோ you get CH2 minus CHO. அது வந்து இந்த கார்பன் அட்டாக் பண்ணும், like previously OH minus attacks there and forms the beta hydroxy compound, the 1,2,3 hydroxy compound. அதுலேருந்து water split ஆகி இது வருது. This is called cinnamaldehyde. This is a common name, is called cinnamaldehyde. This will be phenyl propenoic propenol, 3-phenyl propenol. And இந்த மாதிரி இன்னொரு அசட்டோனை ரியாக்ட் பண்ணாங்க instead of aldehyde. the acetone will condense and will form a double bond. So, you get this similar structure, except CHO you get CH3. Next is a Perkin reaction. The Perkin reaction is similar to all these condensations. You take an aldehyde and react it with acetic anhydride in the presence of sodium acetate. Sodium acetate is a base. Acetate ion can easily react with H plus to form acetic acid. The benzaldehyde plus acetic anhydride will form a CH2 minus here and condense with aldehyde and form C double bond C, which we have seen in the last reaction. இதை வந்து hydrolyze பண்ணாக்க you get this acid which is called cinnamic acid. Aldehyde use பண்ணாக்க you get cinnamaldehyde. If you use this acetic anhydride you get cinnamic acid. Next is benzoin condensation. You take benzaldehyde and react with cyanide in the presence of water and alcohol. Two molecules come together and react to leave with one as carbonyl, the other with a secondary alcohol. This compound is called benzoin. Actually, this is previously used in the alcohol solution, just like tincture. It's called tincture of benzoin. It's used for applying on wounds so that the bacteria is killed. This is another reaction which is called a Dieckmann condensation. You have adipic acid diethyl adipate. Adipic acid reacted with two molecules of alcohol to form the diester. When this is treated with sodium ethoxide, you form an anion here, and this anion formed here will form the enolate, become double bond here, and the double bond here moves to O minus. Here the anion will come back to form the C double bond O. This will attack the carbon of the other. This is intramolecular reaction. Intermolecular reaction is one molecule reacts with another molecule. Intramolecular reaction is the reaction takes place in the same molecule. ஒரே மாலிக்யூலில் ஒரு பக்கம் தி அட்டாக்கிங் குரூப் இருக்குது, இன்னொரு பக்கம் அதை அட்டாக் பண்ணக்கூடிய குரூப் இருக்குது. அது ரெண்டும் ஒரே மாலிக்யூலில் இருந்தால் இட்ஸ் கால்ட் இன்ட்ரா மாலிகுலர் ரியாக்ஷன். இந்த O மைனஸ் இங்கே வந்தாக்க இந்த டபுள் பாண்ட் போய் இந்த கார்பனில் அட்டாக் பண்ணி இந்த OR போடுது, அண்ட் யூ கெட் cyclopentanone. It's a 6-membered ring. It's called cyclic because it's in the form of a cycle. If two carbon atoms are attached at the end, and because of this OR going, this will become a ketone, and this will become the COOR, the COOR. This carbon is remaining here. This carbon is becoming part of the 5-membered ring. So, this is cyclopentanone carboxylic acid, 2 cyclopentanone, 2 carboxylic acid, and this is an ester, so it's a carboxylate ester. Mervyn, Pondorf and Worley reduction. இவ்வளோ நேரம் ஆல்டிஹைட் சிந்தசைஸ் பண்ணுறது எப்படி லேபில் ப்ரிப்பேர் பண்ணுறதுங்கிறத பார்த்தோம். அடுத்தது வந்து கீட்டோனை எப்படி ப்ரிப்பேர் பண்ணுறதுன்னு பார்க்கலாம். கீட்டோன் வந்து it is prepared by oxidation of secondary alcohols. Secondary alcohol சொன்னாக்க இந்த hydroxy group attached to the carbon of the alcohol should have 2 different carbon containing groups. That is called secondary alcohol. Primary alcohol ஒரு கார்பன் தான் இருக்கும், மற்றதெல்லாம் ஹைட்ரஜன் CH3 CH2 OH. CH3 CH2ல இருக்கிற ஒரு கார்பன் which is attached to the carbon of the alcohol. இன்னொன்று வந்து இந்த ஹைட்ரஜனில் இருக்குது, that is called primary alcohol. This is called primary alcohol. இங்கே இந்த ஹைட்ராக்சில் குரூப் அட்டாச் பண்ண கார்பன் ஒரே ஒரு மெத்தைல் குரூப்போடு இருக்குது, ஒரு ஆல்கைல் குரூப். இங்கே வந்து இந்த கார்பன் வந்து 2 ஆல்கைல் குரூப் இருக்குது. இந்த 2 ஆல்கைல் குரூப் அட்டாச் டு தி கார்பன் கண்டெய்னிங் ஹைட்ராக்சில் குரூப். ஹைட்ராக்சில் குரூப் அட்டாச் பண்ண கார்பனோட 2 ஆல்கைல் குரூப் அட்டாச் பண்ணாக்க இட் இஸ் கால்ட் செகண்டரி ஆல்கஹால். Usually in the primary alcohol we have seen on oxidation with pyridinium chlorochromate, it gets oxidized to aldehyde. சாதாரணமாக ஆல்கஹாலை ஆக்சிடைஸ் பண்ணாக்க ஆசிடுக்கு போயிடும், ஆல்டிஹைடோடு நிற்காது. அது ஒரு ஸ்பெஷல் ரியேஜென்ட். அப்போ அதை எக்ஸ்பிளைன் பண்ணேன். இப்போ வந்து இந்த செகண்டரி ஆல்கஹாலை எடுத்துகிட்டு குரோமியம் ட்ரைஆக்சைடு இல்லாட்டாக்க பொட்டாசியம் டைக்ரோமேட், தே ஆர் ஆல் ஈக்குவலண்ட் இன் கெமிக்கல் காம்போசிஷன். இந்த ஆசிடோடு போட்டாக்க இது வந்து குரோமியம் ட்ரைஆக்சைடாக மாறிடும். இந்த குரோமியம் ட்ரைஆக்சைடு ஆர் பொட்டாசியம் டைக்ரோமேட் in the presence of acid, in the OH group it will oxidize to ketone. So you have 5 carbons here. The alcohol group is in the center carbon, 3 carbon. So this will be 3 pentanone. 5 carbon இருக்கு, ஒரு ketone group. Pentane derivative is called 3 pentanone. So this is the general way of making ketones. You take a secondary alcohols. We will see later on how these alcohols are prepared. There is a reaction called Grignard reaction. And the Grignard reaction மூலமா you can prepare primary alcohol, secondary alcohol, tertiary alcohol. The secondary alcohol prepare பண்ணிட்டு அதை வந்து chromium trioxide dichromatoட oxidize பண்ணாக்க you get the corresponding ketone. If you have the alcohol group in the third position, you have 3 pentanone. இதுக்கு பதிலாக இங்கே ஆல்கஹால் குரூப் இருந்தாலும் அதுவும் செகண்டரி ஆல்கஹால், அதை ஆக்சிடைஸ் பண்ணால் 2 பென்டனோன் வரும். எங்கே ஹைட்ராக்சில் குரூப் இருக்கோ அந்த கார்பனில் ஆக்சிடேஷன் ஆகும். OH group will be converted to carbonyl group. Now there is a similar reaction we have seen in phenol. It's called the Friedel-Crafts acylation reaction. You take an aromatic ring with phenol, the reaction is faster. If you treat it with the acid chloride, RCOCl or ARCOCl, both will react. In the case of phenol, the reaction will be fast. You will get orthohydroxy acetophenone if you use acetyl chloride. If you use it also gives a para-hydroxy acetophenone. Both ortho and para isomers are formed. Normally, electron donating substituents like phenol direct the incoming group, that is RCO group, both to ortho and meta position. And the proportion of the ortho to meta can vary something like 3:1, 2:1, or the less ortho and a little more para, because there are 2 ortho positions and 1 para positions. And the reactivity ஒரே மாதிரி இருந்தனாக்க you should get 2 ortho and 1 para. But அந்த ortho வந்து hydroxyl group பக்கத்தில் இருக்கிறதுனால usually some steric indents will be there. The 2 isomer will be formed to a lesser extent. Now we look at this formation of ketone from aromatic hydrocarbons like benzene. You react with RCOCl in the presence of aluminum chloride, which is the catalyst that is used for Friedel-Crafts acylation. So this will become reaction of RCOCl with aluminum chloride. Chlorine will leave as a chloride ion, it will get attached to the aluminum chloride. Aluminum chloride is called a Lewis acid. It can take another chloride ion to form aluminum tetrachloride ion. This becomes RCOCl. It may not be complete cation, கொஞ்சம் delta positive இருக்கும், இது delta negative இருக்கும். The delta positive end, this will react with the benzene ring to give the substituent RCOR. RCOCl, RCO group will be attached to Ar. If it is ArCOCl, it will be attached to ArCOAr. That's benzophenone. If you use acetyl chloride, that is acetophenone. So this is how the keto group containing an aromatic ring is formed by what is called Friedel-Crafts acylation reaction. There is another reaction by which ketones can be produced. This is with use of organocopper compounds. This kind of reaction starts with R prime X halide with lithium. Lithium metal very easily reacts with R prime X to form R prime Li plus LiX. You have to use 2 atoms of lithium and you get 1 molecule of LiX, another molecule of R prime Li. If you treat this R prime Li with cuprous halide, where copper has valency 1, copper has 2 valencies, copper 1 and copper 2. Copper sulfate CuSO4, the valency of copper is plus 2. Here the copper is plus 1 CuX. If you treat this with the CuX, you treat 2 molecules of R prime Li with the CuX, you get 1 molecule of R prime Cu R prime, another molecule of LiX. The lithium reacts with copper, it forms LiX, and another molecule of Cr prime Cur prime. So this is the lithium dialkyl copper. This is lithium is part of this molecule. It's become lithium dialkyl copper. So this in this the R prime is, let us put it like this. There are 2 negative groups, R2 R prime, 2 of them are negative. Copper is 1 positive ion, counter ion, lithium is 1 counter ion. These are not fully ionic compounds, they are partially ionic. This copper and lithium will have partial positive charge, R2 minus will have partial negative charge. எப்படி இருந்தாலும் இந்த R2 வந்து has negative charge, and because it has negative charge, it will attract the carbon of the carbonyl group. Carbonyl group, we have in the first slide itself we have seen delta minus, delta plus. This we have delta minus, the delta minus will go and attack the carbon which is delta plus. So the R group will attack the carbonyl group to form, once it attacks, in this case the chloride will be removed as chloride ion. So you will get RCO R prime. Suppose you have this the R prime attacks the carbon and removes the chlorine, you get R prime CO R. That's the, if you have aryl halide, aryl COCl, acid chloride, benzoyl chloride, you get ArCO R prime. So the R and Ar comes from the acid chlorides, the R prime comes from the lithium dialkyl copper. This is the reagent that is used to produce ketones, and this is a very versatile method used for large number of ketones.